Bismillahirrahmanirrahim. In this video we will discuss about the parts of our DC machine. Here you can see an open DC machine and you can visualize that how a DC machine works. So now I will explain you about the different parts of this machine. Here you can see some coils. These are the coils of the field winding because magnetic field is required for the working of the DC motor. So we inject current in this winding, that is the field winding, and these are the coils of the field winding. So a magnetic field is established. So magnetic field is obtained with the help of this one, and this one is basically the core of this field winding. And here you can see it is laminated, that you can observe over here. Laminated sheets are stacked together to develop the core of that one, and the purpose of this lamination is to reduce the eddy current losses. And the material of this one is selected to control the hysteresis loss. This is the static part of your machine. It does not rotate, it is fixed. The purpose of this is just to provide the magnetic field. So we inject the current in this winding and develop the magnetic field, and for that we will use the supply, and we will inject the current, and a magnetic field will be developed that will link with the conductors which are placed in the armature. So armature winding is there, that if I go close you can see the armature winding, and the end terminals of the armature windings are connected over here with the commutator segments. So these are the commutator segments, right? These are basically the end terminals of the copper winding, or you can say the loops which are placed over the armature, right? And this part is the rotating part. As you can see, I am rotating it, so it rotates in the magnetic field. So if we rotate it in the magnetic field, so according to Faraday law, when there will be a change of flux in the conductor, there will be an induced EMF. So induced EMF will be there on the end terminals of this winding. So that is collected with the help of these carbon brushes. This one is the carbon brush, this one is the carbon brush, that you can see are connected, are placed over the commutator segments. Carbon brushes are fixed, they do not change their position, but armature rotates. So if we rotate it with the help of prime mover, so EMF will be induced, and that can be collected over here, right? So this one is the shaft. Your armature is the rotating part. Armature core is there inside. If you can just look at it inside, here you can see some slots. Armature winding is placed over there, end terminals are over here over the commutator segment, carbon brushes, and this armature is suspended in the magnetic field. So for that you can see this shaft. There are bearings over here, one bearing over here and one bearing, as you can see over here. So it is suspended in the magnetic field, and once we rotate it with the help of certain external prime mover, and EMF will be induced, and that will be available over here, and we can use it in the external circuit, right? And if we want to use it as a motor, we will have to inject the current in the armature winding. So for that again we can use this source. So we will inject the current in the armature, and how we will inject? So the machine supply terminals over here, coming over here towards the carbon brush. So armature winding terminals are these two carbon brushes. So we inject the current in the armature with the help of these carbon brushes. So it becomes a current carrying conductor placed in the magnetic field. So a force will act on it and it will start rotating. So how the force will act? Let's suppose this carbon brush is connected with a commutator segment whose conductor is over here at the moment, and the other carbon brush that you have seen over here, its conductor, this carbon brush is connected with the commutator segment whose conductor is, let's suppose, on the opposite side. One loop goes from here, from the back side it comes like that, it's connected over here. So this loop, when you inject the current in that one, it's a current carrying conductor placed in the magnetic field. So a force will act according to the direction of the current. So a couple of force, maybe in this direction over here and in the opposite direction on the other side. So it will start rotating, and it will become the motor because your electrical energy is converted into the mechanical energy. It is giving you the rotation. So now let's inject the current in the field winding as well as in the armature winding. So if I inject the current, so it will if I inject the current in the field winding, magnetic field will be established, and then if I inject the current in the armature, so you will see a force is acting. So let's increase the voltage, apply it on the terminals. Here you can see now the current is injected in the armature, so it has started rotating. Why? Because a force is acting on this armature, right? It has become a current carrying conductor placed in the magnetic field. So if I increase the current, here you can see its speed is increasing, right? So armature is the rotating part and your field winding is a static part in this particular machine. So there are two basic classifications. One is the set of static parts and the other one is the set of the rotating parts. So your field winding, as you can see over here, is static. It is not rotating, right? Your field winding is static. Your pole shoes are static. Your core of the field is static, but your armature is the rotating part. Your armature core is rotating. It is mounted over the shaft. There is a winding over the armature that is also rotating part because it rotates when you inject the current in that one. And your commutator segment, let's run it and see it from the top. So here you can see the commutator segment. It is rotating, end terminal of that one, and your carbon brushes are fixed. So commutator segments are changing their position. One particular set of the loop come in front, it gets energized, force acts on that, then the other it moves onward. Next pair of the next loop comes in front of the carbon brushes, gets energized, force acts, it rotates, and this procedure goes on, and a force acts on the armature and it starts rotating. So if you increase the magnitude of the current or you inject more current, so you will see the speed of the machine will be increasing with the increase of the injected current. Why? Because more force will act over the armature, right? So your carbon brushes are static. You can observe in over here. Carbon brushes are fixed. They are not rotating. This is the rotating part, the armature winding and the commutator segment. This is the rotating part, and this armature is suspended in the magnetic field on both sides. This assembly has been developed to demonstrate you, and there are the bearing inside. Ball bearings are used. So suspended armature is there, and when it becomes a current carrying conductor in the magnetic field, it starts rotating, right? So that we have studied in the theory, and now it has been explained over here. This machine can also be used as a generator. In that case, you will have to rotate it externally by some prime mover, and the induced EMF will be available over these carbon brushes. Carbon brushes are the static part, right? So if I summarize the list of the parts, you have the armature, rotating part, commutator segments, armature core, and the shaft. This one is the rotating part, and in the static part you have the field winding, pole shoes which are there inside, the field winding core, and field winding core and the armature core is made up of thin laminated sheets to reduce the eddy currents, and the material of these cores are selected to minimize the hysteresis losses as we have discussed in the theory class. So these are the parts of your DC machine. Mechanical parts are these ones. Shaft is also a rotating part, and there are the ball bearings inside that you can observe from here. So this is the summary of the parts of the DC machine, and summarizing that how it works. When you inject the current in this winding, it becomes a current carrying conductor placed in the magnetic field, and a force acts on that one and it starts rotating, right? So if you will increase the current in this one, more force will act and speed will be increasing. Rest of the things we will discuss in the theory class. The purpose of this video is to just demonstrate the parts of the DC machine in detail, so that you can visualize that what we are studying in the theory, how it is correlated with the actual structure of the machine. So this is the demonstration of all what we have studied in the theory class. That's all from this video. Thank you very much.